Okay, I'm going to take a few minutes and go over this Itec system I've got here. This is something that should have been done a long time ago. I apologize it's taken me this long to get it. I just thought to myself, I'll grab the video camera and try to knock this out, just so that you guys have some point of reference. I'm not going to guarantee that this thing is going to hit every question and every scenario and every aspect of this system, but I'm going to try to do the best that I can with the knowledge that I've got in order to help you guys understand this, and maybe a little easier to get to some of the parts that we're referring to when you've determined that you've got an issue. Basically goes like this. This is what you're looking at when you're opening the hood, right? You got your radiator hose coming in here, you've got the intake plenum here. Come around the front side of it. This is the throttle where the air actually goes in. You know, you're pushing on the gas pedal, it's letting the air in through here. The fuel injection rail is right down here. It sprays fuel right into the air that's being drawn into the cylinders right before it enters the cylinder. You've got the thermostat housing right here. This is the vacuum switching valve that will cycle on and off when your truck's running hot, typically when you're low on coolant. A lot of times indicative of a blown head gasket. These linkages right here are known to wear out. The bushings in here will wear out, causing inconsistent idle. This hose right here is a bypass. It comes off and it runs down between the runners to the idle air control valve. And this is what the ECM uses in order to increase or decrease the volume of air going into the common chamber. It's activated on startup. It'll open up. The ECM will richen the mixture, sort of just, you know, like a choke would on a carburetor. So when guys are referring to your idle air control valve being stuck, either open or closed, and they say, you know, take a can of Seafoam or WD-40 or liquid wrench or whatever, what they're talking about, you know, from your perspective is you go to the back of the throttle here. That's your hose right there. You break it off, and what happens is the solvent runs down and it soaks right there through that valve, and oftentimes frees that up and gets it going again. Fuel injectors are attached to this rail right here. It runs under the common chamber, and then the injectors come off there one at a time, and they've got a rubber seal here and rubber seals here. This is your fuel in to that rail. The fuel pressurizes this rail. The injectors squirt when they're ordered to by the ECM, and the rail exits here into this hose, which comes out here on the other side of your Itec, and that's your return line, which on 89 to 91 models, you'll have a fuel pressure regulator here. That's actually kind of like a backstop. That's what keeps the pressure inside of the rail and inside of the injectors. On the 88s, this hose comes over and attaches on the fender well. Right here on the lower side of the plenum, this is a thermal switch. This is for an automatic. This intake happened to come off of an automatic. You'll only see this on the automatic versions. And this kicks on when the engine is up to temp and helps control the transmission shifting. I believe it doesn't allow the transmission to go into overdrive until after the coolant inside of the intake is up to temp. This is the coolant temperature sending unit that supplies information to the temperature gauge on your dash. And this, I apologize, but this is the baby blue vacuum switching valve, which basically does the same thing that this one does, only it opens a vacuum port, and if you can see, vacuum is supplied from a port at the very bottom of the throttle, which is really difficult to see and extremely difficult to get to when this is mounted on the vehicle. Okay, so these are the two ports I was pointing at, kind of at that same perspective if you were looking from the underside of the intake. From the upper side, this thing is mounted like this, and I was, you know, showing the inside of it, flapping the valves a little earlier so you can see where those things are. That's a real common problem because people are just completely unaware of them. Another issue with this is these two water lines right here. These two water lines come in, and these hoses are impossible to see, very difficult to get to, and can be very problematic if you're, out on the road and one of those hoses bursts and you start losing coolant. Here is your throttle position sensor. Okay, here's the lower section of the intake as you would see it from looking down. That's where your thermostat housing bolts in. This is where your injectors plug in. These are where your injector rail bolts on. These are the studs that bolt into the head. This is where the upper plenum, that big rectangular piece that says Itec, that's where it bolts on. You got a water inlet here that provides water through the intake. There's that blue switching valve I was referring to that goes up to the throttle and then onto the EGR valve. Here's another real big problem. These are the two water hoses that I was just showing that go to the throttle. And then here is another one. And this one runs through the intake up through here. I'm going to kind of give you some perspective on this. This is the hose I'm referring to on the lower side of the intake. This is your cylinder head right here, your block below. This hose, all the way down here, it runs up through here, which, imagine trying to get to that from this side, okay? If you're on this side of it and looking at this problem, it is right here. Just inboard from your blue thermal switching valve, your coolant temperature sensor, and if it's an automatic, you've got the switch here. This hose right here, very, very common that this hose will burst. Typically it happens right back here, I imagine, because this is probably one of the hottest spots on the motor. You're right next to the cylinder head, buried under all of this stuff, and this hose bursts right in here. And you can imagine how much fun that is to replace on the side of the highway. EGR, back pressure transducer here, controls your EGR valve back here. This is where your brake booster comes in for manifold vacuum. This is your coolant temperature sensor. You can see your coolant temperature sensor there. Not your coolant temperature sending unit. Coolant temperature sensor is what sends a signal to the ECM, telling the ECM what the temperature is inside the intake. This is the igniter for the electrical system, and fuel injector, EGR around the backside here. This is an automatic, so you've got one extra feature here. This plug right here only applies to the automatics. Now here's something interesting. If you are doing a motor swap or an top end intake swap, something like that, and you don't notice that your throttle position sensor has two wires coming out of it instead of one, and you install a motor out of a 5-speed, everything will plug in, and you'll have a truck that will not shift gears. So if you've got that problem, there it is right there. You need to change, actually you need to change the entire intake. You can get by with just changing this entire wiring loom, but taking this whole thing apart, that's up to you. Watch my video on Itec removal and make your decision. On the top side here, you've got a very small vacuum port that goes to the firewall where your AC lines go through. That goes and controls that the flapper inside of your AC. This is the other side of your idle air control valve. As the idle air control valve opens and closes, it's just letting air into the common chamber here through this relatively large port right there. This goes to the purge of the side of the vapor canister, so when it's activated by the switches on the fender well, it sucks the vapors out of the charcoal canister right through here. You've got stuff over here. This goes to your fast idle solenoid, and one of these goes to the driver's side fender well, and that one runs over to the switching valves on the fender well. Okay, now I'm going to try to go over this whole thing in a nutshell here, try to tie it all together. You've got the air cleaner here. Fresh air comes through it. This is your mass airflow sensor, sends information to the ECM. The air runs through the intake tube. This gets branched off to your vacuum switching valve. I'll come back to that. This runs over into the valve cover, and what it's doing is fresh air is being sucked off of the supply here and into the motor. It runs into the valve cover, passes along the valve cover here, picking up any vapors from the crankcase, and then they are sucked back into the common chamber of the intake and presumably burned in the cylinder. Your air comes in here. Your butterflies are open and closed and control the volume of air that runs through the throttle. Air runs into the common chamber and then is sucked through the lower runners, and the injectors spray fuel into it just as it comes into the head. Aside from that, that's the stuff you need to make it run. You know, fuel pump, fuel pressure, air, and that's about it. Now, we've got brake booster off of here because that's necessary. When you get this engine hot, or if you get air, as I found, if you get air in the system, this switching valve will start kicking on and off and on and off. And what it's basically doing is, you've got fresh air coming right off here, and this switch opens and closes, and it lets fresh air right into the common chamber, just immediately bringing the RPMs up and down, you know. The other leg of this runs over here to this metal bracket, metal pipe, and out and over here to the fast idle solenoid. This is activated by the switch on your heater and air conditioning controls. When you turn the AC on, or any of the places that there are lines, anywhere that there's a line going up here where you've got max norm by low, that's going to kick on the AC compressor and also kick on the high idle solenoid, which will bring the idle up in order to compensate for the load of the compressor. So basically all it does is it just opens a valve, and it allows that much more air directly into the common chamber, and the ECM compensates by adding more fuel, and it just brings the idle up and offsets the load of that AC compressor. That's your fast idle solenoid. You've got two vacuum switching valves working here. There's a plug to them, and this receives signals from the ECM telling them to open and close. Vacuum is supplied off of your intake into these two, and you've got this one here with the little round hat on it, and then you've got the other one next to it on the other side here where the plug goes in, and it's got two ports coming out of it. So when you're referring to the diagram under your hood, that's how you figure out what they're referring to. And one of these is the fuel pressure regulator, and what that does is when you are cruising and the vehicle is in motion and the vehicle is in gear and the clutch is not engaged, all of these conditions are met. It assumes you're decelerating, and it reduces the fuel pressure, and makes it run cleaner and save you fuel, increasing the mileage presumably. Okay, all the vacuum routing is laid out here. This is the intake plenum they're showing here. Those are those two ports that are on the bottom side of the throttle that I was telling you about. They come out of the bottom of the throttle and come out over here. And you can see that one of them runs over to the, there's it called an F connector, or basically it's a vacuum T right down in there. And that breaks off and runs over here to the vacuum switching valves, and you can see how they're allocated. One comes over to this T, that branches off to the fuel pressure regulator. There's your fuel pressure regulator. There's the branch. That's where the vacuum line comes in. And the yellow one runs over to pulls the manifold vacuum here, ported vacuum from over here, and controls the fuel pressure regulator through a signal from the ECM. So you've got ported vacuum from right under the throttle, running over to a splitter, and running over to these two switching valves. When the vacuum switching valve here opens, this is the one with a round hat on it. It pulls on the diaphragm in the vapor canister and vents the vapors into the common chamber. The vapors come out of the large valve, right up the vapors out of the charcoal canister right through here. Okay, so we've got the vacuum to the vacuum switching valves on the passenger's fender covered. You show this goes, to the one-way check valve from the fuel tank. Now, EGR valve is mounted right there. Valve back here, mounted on the back of the intake, and then you've got that back pressure transducer. Back pressure transducer here, right here. That runs to a metal line over to that little blue switching valve. Fast idle solenoid, and when it opens, it runs vacuum right back into the common chamber. PCV line comes right out of the top of the valve cover over to the common chamber. That's your black thermal valve that's in your thermostat housing. Throttle valve, they're referring to your butterfly throttle there. Vacuum switching valve, that's this one over here that sits right there. That runs all your smog pump stuff. Okay, now this other vacuum line here on the front of the intake runs across the front of the motor, across the valve cover, and over to your vacuum switching valve on the driver's inner fender, which is just in front of the hydraulic clutch dampener. And this stuff controls the air pump. A lot of people just refer to it as a smog pump. It pumps fresh air down this air rail, injecting it into the exhaust ports to aid in the combustion of the unspent fuel when it reaches the catalytic converter. Okay, the wiring loom here comes off the front of the Itec. Underneath here comes over to the passenger's fender well and plugs in. And this one here, this is what goes directly to your coil. You've got a hot and a ground, and the ground also supplies information back to the tachometer. That's where your tach comes from. Okay, the bigger plug controls everything else. The injectors and all the other places that this thing plugs in. Coolant temperature sensor, idle air control valve, throttle position sensor, the whole 9 yards. This here jumps over to the resistor pack. Sits right there on the passenger side inner fender, right above the fast idle solenoid, which I've never really gotten into, never had any issues with that, but evidently it controls the fuel injectors to some degree, in some manner. This system, this system works fine. When it was brand new and all of these parts were new, this was cutting edge. I'm sure these things ran great. You get 150, 200,000 miles on them. They're 20 plus years old. You start having some problems maybe with some of the components, and then this becomes a pretty big headache, especially when it's on the side of the road. The biggest issue with these is fuel pressure. The fuel pumps that are out there today, aftermarket, from my experience, are junk. They don't last very long. And I think that the fuel that's out there today is also attributing to the problems that people are seeing with these. I'm not saying they can't be made to run right. Sure, okay, so best case scenario, you've got one of these that's completely rebuilt and runs great. That's your best case scenario. This is what you're using for engine management. I haven't even gotten into the electrical system at all, but this is what you're working on, on your weekends if this thing starts giving you trouble. This is how I prefer my Trooper. We've got a long block with an exhaust manifold, some spark plug wires, and an alternator on this side, a distributor coil a carburetor, and an intake manifold. And this is the wire I was telling you that comes off your fender well. It goes to your coil, and you just make a jumper right here, and it fires up your distributor and your coil. That's it. This is a condenser that you can choose to run if you want to. I haven't gotten mine plugged in. There's a hot wire to my choke, and last but not least, a fuel line. That's a Weber 3236, $250 on eBay I think it was, and that's how mine runs. Step your foot on the pedal, it opens the butterflies, fuel and air gets sucked through the air filter, down through the downdraft carb, into the intake manifold, and into the head ports. Very basic. Vacuum to the brakes. And everything else is capped off on the intake so far as vacuums go, except for vacuum advance. Vacuum advance runs over here, and that's what makes this thing run. That's how complicated it is.